I'm going to show you how to solve a combination resistor circuit. Today we're going to start with a parallel in series circuit. So there's my circuit. There's my voltage. So we are going to start by making a VIR chart, as you will with every one of these problems. One row for each resistor and one extra for the total. So I'm going to label ohms up here. This is amps, and volts is volts. When we do VIR charts in complex circuits, what you want to do is figure out where the combinations are. In this case, we have two. We have a parallel, and then we have a series. So when we go to find our total, let's add 30 down here. When we go to find our total, because this is the next open box, we want to start from the inside circle and work our way out. So we want to combine these two in parallel. So 1 over 20 plus 1 over 10 is 1 over R total. When we calculate that out, we get R for that parallel branch of 6.67 ohms. Now that is in series with the 15 and the 30. So we're going to add all of those together, and we're going to get a total resistance of 51.67 ohms. Now the way the box is set up, remember that the next time we get a single open box, that's what we fill in next. So next we find I total. So 30 divided by 51.67, 0.581. Alright. Now what we're going to do, we have open boxes, no single open box. So we have to look at the rules. You look at the last thing you did with resistance, which was series addition. In series, we also know that current is the same and voltage adds. So we're going to start with current. As we trace this around the circuit, we see that I total goes through the 15 ohm, but then it splits up. We don't know how. Comes back here, continues all the way around back to the battery. So over here on my chart, I know that the 15 ohm resistor gets all the current. I also know that the 30 ohm resistor gets all the current. Well, now we have an open box. We're left with an open box. Two open boxes, actually. So the 15 ohm resistor gets a voltage of 8.72 volts. The 30 ohm resistor gets a voltage of 17.43 volts. What that means is that here to here we use 8.72. Across this resistor we've used 17.43. knowing that voltage adds in series, what's left from the 30 goes across the parallel branch. So we're going to subtract the other two voltages, and we're left with 3.85 volts. 3.85 volts. That I'm going to write over here. Now, this branch is in parallel. And we look at the parallel rules now. We don't know the current, but we do know the parallel rules. Parallel, voltage is the same. And since there's only one resistor in each of those branches, that one resistor gets the entire volt. So both of these resistors get 3.85 volts. Now we can figure out the current by taking voltage divided by resistance. 0.193 for the 20 ohm and 0.385 for the 10 ohm. Now, it's not going to come out to be perfectly added to get 0.581, just like the voltage over here won't add perfectly to give us 30. If you take the 8.72, the 3.85, and the 17.43, well, that one will add because we subtracted to get the 3.85. But to adding the currents, because of rounding, we're not exactly always going to get the numbers to add up exactly. But that's okay. So this is how we would do. This is what we call a parallel in series.